Welcome to Sravz technical series. This is session 3 of historical ticker plant discussion we have been having. So in the session 2, I'll do a quick recap. In the session 2, we discussed the internal structure of the Rust ticker plant. We discussed about the router, which is a dependency injection, and then we created a service called leveraged fund service, which was able to pull data from S3 and then create Polar's data frames. So we discussed all that in this video explanation. So please go through that before going through the session 3. So in today's session, I updated the data flow diagram to focus on the leveraged fund surveys. So in the leveraged fund surveys, we have a data frame which has the data for the three leveraged funds of NASDAQ 100, TQQ, QLD, and QQQ. Now, once we have that data frame, for today's session, we just want to plot the data frame to do an exploratory analysis of the data. So for that, we have used Py03, Py03 service, which is an integration with Python. So in Python, we'll use matplotlib to generate a PNG file of the data. Polars natively doesn't support a good charting framework. So until then, we'll just use Python's matplotlib because it's feature rich and do exploratory analysis. And also, once we have that matplotlib PNG file, we'll upload that to S3 and then display that in the UI through Angular application. So to send the Polars data frame from Rust to Py03, there is no native data structure in Py03. So instead of sending it through memory, for today's session, we just create a Parquet file, save it to the disk, and Python will pick that Parquet file and create a data frame. So that way we'll use the disk to transfer the data between Rust and Python. So again, at the high level, these are the discussion points. Py03 integration, pass Polar's data frame to Python, review matplotlib output. So before the review of the code, I'll just run the Rust application. So I'll go to the leveraged funds again, and then I'll run the test case. So I'll run the test case from the command prompt. The code is shared here in the code references, so you could get it from GitHub as a gist. So I'm running the same code via VS Code. I'll run the test case again. So this is the command cargo test, run the test case. So it's running. We have discussed this output before, so we'll skip the output. So this is the data frame. And then there's some Python process in progress, leverage funds.py. So once that is done, the Python code generates this file. So we'll open that file, the PNG file. This is the image generated by the Python code. It does a summary statistical analysis of the data frame, and we have gone through this discussion in a previous session in the analytics section in rolling statistics discussion. We went through that image. So today we won't discuss this image, but but today we'll just show that from Rust we are able to call Python, and Python is able to generate the images for this. And to generate the same in Rust will take a lot of time, so we don't want to do something in Rust which will take longer time, which can be easily done in Python. So now I'll switch to the code base. So this is the Py03 service. It's a new file. So we have used bunch of imports. Then we used Py03 module. In Py03, we do Python with kill so that we log the global interpreter log of Python. Then it's a lambda. To the lambda, we update the Python path and then call the run function in that Python code base. and then to that Python code base we just execute it by sending the function name as the parameter. From the function name parameter, the Python code base will have access to the data frame which is saved to the temp directory. So I'll switch to the other VS Code. So we don't, in temp directory, we create a Parquet file of the pandas data frame, and Python code will pick that Parquet file to create pandas data frame. So switch back to the VS Code. So that's the Python integration with Py03. Then we have a bunch of Python modules here. We have the main module. The main module will pick the file from temp, the function name.parquet file, loads the Parquet file as a pandas data frame, then sends it to the leverage funds module. Then we go to the leverage funds module, leverage funds.py. The leverage funds.py will take the data frame, the function name, and then it will create those summary statistics, which we discussed in the analytics section. I showed you in the rolling statistics discussion, so you could go through there. But this is all the code we have for the rolling statistics, and finally it will save the file to temp directory with the function name.png. So that's how the Rust application will get the PNG file, and then it will save it to S3. I'll close that out and then go to the leveragefunds.rs file. In the leveragefunds.rs file, we discuss this whole code base. Now we call the Python module, pass the data frame and the function name. Then the Python code will run it in the background and create that PNG file. Then once we get this leveragefunds.png file, we'll upload that to S3. So we added a new function to S3 module called upload file, and then that module will upload the file to S3. I'll quickly open that updates to S3. S3 module.rs. We added this new function upload file, which will take a bucket name, object name, and the file path, reads the local file into memory, file content, then uses put object request to put that file in S3 using client.putObject. So that's how the JPEG file we just opened will be loaded to S3. So this is the PNG file we created. This PNG file is uploaded to S3. Then Angular application will pull this image from S3 and then display it in the UI. So for today, we just did a high-level exploratory analysis of the data frame. In the future sections, we'll try to analyze these three symbols, TQQ, QLD, and QQQ, and see if the volatility for TQQ is 3 times of QQQ or it's much larger than QQQ, because the leverage funds promise us to give 2 times, 3 times of the returns, but we want to check if the volatility associated is also 2 or 3 times or it's much larger. So that's for the next video. So for today, I'll close this session. If you have any questions or comments, please reach me out in this discussion tab or in the YouTube channel. So until next video, thank you.